Hey everyone, welcome back to the channel. If you're preparing for a role in AI, data science, or machine learning, you've probably heard the buzz around generative AI. It's one of the hottest topics in tech right now, and it's showing up in interviews more than ever. In today's video, we're diving deep into top 12 generative AI interview questions. And I'm not just giving you the questions, but also clear, concise answers and explanations to help you stand out. So, let's get started with our first question. What is generative AI? And how does it differ from traditional AI? So, answer for this question is, generative AI can create new data, like text, images, and music, that resembles the data it was trained on. It learns patterns and then generates something original. Traditional AI usually analyzes existing data to make predictions or classifications, not create new content. The next question is, explain the basic principles behind generative adversarial networks, GANs. And the answer for this question is, GANs have two main parts, a generator and a discriminator. The generator tries to create fake data, and the discriminator tries to tell the difference between real and fake data. They compete, and the generator gets better at creating realistic fake data through this competition. The next question is, what are large language models, LLMs, and how do they relate to generative AI in text? The answer is, LLMs are generative AI models designed to understand and create human-like text. They are trained on huge amounts of text data and can perform tasks like writing articles, translating languages, and answering questions coherently. For example, ChatGPT and Google's Gemini are examples of LLMs that can generate text. Fourth question is, explain the concept of latent space in the context of generative models like variational autoencoders, VAEs. The answer is, latent space is a hidden, compressed representation of the input data learned by models like VAEs. It captures the essential features of the data in a lower dimension. By sampling from this latent space, the model can generate new data that is similar to the training data. The next question is, what is mode collapse in GANs and how can it be addressed? And the answer for this question is, mode collapse happens in GANs when the generator produces only a limited variety of outputs, often repeating the same few examples instead of capturing the full diversity of the real data. Techniques like mini-batch discrimination, looking at groups of generated samples, using different loss functions, like in Wasserstein GANs, or adding noise during training can help prevent mode collapse. The sixth question is, how do you evaluate the performance of a generative model? What metrics are commonly used for image and text generation? The answer is, evaluating generative models is tricky because we want them to be realistic and diverse. Common metrics include, for images, inception score, IS, measures the quality and diversity of generated images. Higher is better. Freshe inception distance, FID, compares the generated images to real images. Lower is better. For text, perplexity measures how well a language model predicts text. Lower is better. Bell-U score compares generated text to reference text. Higher is better. Human evaluation, asking people to judge the quality of the generated content, is also very important. The seventh question is, what are some of the key applications of generative AI across different industries? The answer is, generative AI has many uses, including content creation, generating images, videos, music, and text for entertainment and marketing. Healthcare, designing new drugs and creating synthetic medical data for research. Manufacturing, generating new product designs and optimizing existing ones. Gaming, creating realistic game worlds and characters. Eighth question is, what are the ethical considerations and potential risks associated with generative AI? The answer is, some ethical concerns include bias. Models can generate biased content if their training data is biased. Misinformation. Creating realistic fake images, videos, and text, deepfakes, can be used to spread false information. Intellectual property. Questions about who owns the content generated by AI. Job displacement. Concerns about AI taking over creative jobs. The ninth question: how can you control the output of a generative AI model to achieve a desired style or content? The answer is, you can control the output through prompt engineering, carefully designing the input prompt to guide the model. Conditional generation. Training the model on labeled data so you can specify attributes, like style, during generation. Fine-tuning. Training a pre-trained model on a specific dataset to adapt its style. The 10th question: how do GANs differ from VAEs? Answer is, GANs and VAEs are both generative models, but they work in fundamentally different ways. GANs, generative adversarial networks. Think of them as a game between a creator, generator, and a judge, discriminator. The creator tries to make fake data so good that the judge can't tell it apart from real data. They improve through this competition. GANs excel at generating very realistic, high-quality samples. VAEs, variational autoencoders. Think of them as learning a compressed, understandable data representation. They learn to encode data into a latent space and then decode it back. VAEs are good for learning the underlying structure of the data and generating new samples by exploring this learned space. The next question is, how generator and discriminator work together in GANs? The answer is, the generator and discriminator in GANs work together in a continuous loop of creation and judgment. Generator creates. The generator takes random noise as input and tries to transform it into synthetic data, e.g., a fake image. Its goal is to make this fake data look as real as possible. Discriminator judges. The discriminator receives both real data from the training set and the fake data produced by the generator. Its job is to correctly identify which data is real and which is fake. The last question is, what is prompt engineering in large language models? The answer is, prompt engineering in large language models, LLMs, is like carefully crafting the instructions or questions, the prompt you give to the model to get the specific and desired output. Because LLMs are so powerful, the way you phrase your prompt can significantly impact the quality and relevance of their responses.